Hi there, welcome to another video. The last maths video I did on the channel was actually about a little roadmap that explained a little bit what were my goals in mathematics. Not everything, but like what I wanted to do, mostly up to topology. And I mentioned that I kind of need to learn analysis for that. And today's video is actually going to be more on analysis. I have prepared with me a bunch of books on analysis that I would like to present. They're not in a particular order right now, but I will order them towards the end of the video and will tell you like a concrete order of what I'm going to go through. And the first book I would like to start with is actually this duology from Terence Tao, which is an amazing, very popular mathematician. You've probably heard of him. And he wrote these two books on analysis. This is more like a real analysis, volume 1 and 2. Let's quickly look at the table of contents. Each book has both table of contents from what I've seen. So yeah, this is volume 1, like introduction, some narrative stuff, then the natural numbers. It starts with the Peano axioms, which are really important and not a lot of books start with, but I found them really interesting and I think they are pretty important to mathematics. Then some set theory, integers and rationals, so like numbers, the real numbers, limits of sequences, series, infinite sets, continuous functions on R, differentiation on functions, the Riemann integral, and then appendix. Let me turn the page. Appendix A and Appendix B. Then starts the second volume. Well, let me actually go to the second volume, which is considerably thinner than the first volume. Now these are library copies and they're also paperbacks. I've seen that on Amazon you can get them as hardcovers only, or at least they don't have them in paperback in stock right now. But yeah, let's look at the second copy, which has a removable set of papers. I don't know, maybe this fell down, but I've seen like all of the copies from our university library had this problem. But yeah, chapter 12, metric spaces. I read a part of it and it's pretty interesting. Like, I enjoy reading about metric spaces. And then continuous functions on metric spaces, uniform convergence, power series, Fourier series, several variable differential calculus, Lebesgue measure, Lebesgue integration. Oh, this is uncomfortable. And yeah, that's it. Like, Fubini's theorem is the last thing from this book. It's treated as just one book. Like, the table of contents does say page 600 and something at the end. Let me actually check if the numbering system inside the book. Why doesn't this open? Oh yeah, it's actually a continuation of the first book, so page 515, just like a continuation of the first book. But yeah, can't wait to go through these. They are in English, and I'm really excited, but I don't think I'm ready for them. Like, I expect some pretty difficult stuff. You know, Terence Tao is a genius, so maybe some of the problems that he wrote for this book are less intuitive and might be more complicated. But yeah, let's go to the second book, which I have mentioned before on the channel. This is Übungsbuch zur Analysis 1, which means like a problems book for analysis 1. Now, in Germany, at the university level, we don't have calculus. If you're doing a math major, you're not doing calculus, you're doing analysis 1, 2, and 3, which is basically calculus but more rigorous and proof-based. But it's not quite real analysis yet. I'm not sure how it is like in the States and stuff, because I haven't studied there. But yeah, this is what it covers. I'm gonna translate a little bit. So like, this is induction, the like axioms of objects. This is how we call them in both German and Romanian. Okay, then the ordering axioms, then we have limits and series, then the axioms of how do I translate Vollständigkeit, like completeness, something like that, then the radical, then the convergence criteria for series, the exponential series, some sets, functions, yeah, logarithms, complex numbers, trigonometrical functions, differentiation, yeah, like the mean value theorem, the integral, integration and differentiation, inequalities of integrals, the gamma functions, Taylor series, Fourier series, and that's it. Only 46 pages of problems, and the rest, like 80 pages. Wait, no, even more than that. Like what? Yeah, like 100 pages is just like answers. So these are just the type of problems. They're mostly proof-based, like almost all of them. And kind of like an extension to that is actually this next duology that I'd like to present. This is Etwas Analysis. It's in German as well, and the second volume is Etwas mehr Analysis. They actually have a third volume called Etwas mehr Analysis. No, this is the second volume. What was the third one called? Noch mehr Analysis. So this one translates to something analysis, something more analysis, somewhat more analysis, and the third one is even more analysis. This equates to analysis 1, analysis 2, and the third one is analysis 3. I haven't borrowed that one yet. These are both library copies. I actually started working through this one. I'm on page, where was I? I'm on page 54. I started doing the exercises for the second chapter, which talks about real numbers. So let me actually show you the table of contents, since you might not be familiar with the German educational system and what we do over here. Well, not me, because I'm doing engineering and I'm not doing analysis. I'm actually doing like higher mathematics 1, 2, and 3. So yeah, it talks over like logic, set theory a little bit, functions, then real numbers, yeah, then natural numbers, and so on, complex numbers, series, integration, differentiation, which is a nice thing to see. Like, he changed a little bit the order, just because it's more intuitive to think of integrals rather than differentiation. Then what else? Like some other things, and this is elementary ordinal differential equations, like some easy stuff. This is basically a first semester course in analysis, and this author for all 3 books of the series, Jürgen Pöschel, is actually a professor at our university, the University of Stuttgart in Germany, and he published at Springer, but they have, like at the library, they have a ton of copies from this series compared to all the other series. And this is actually the first series, or the first book I will start with. I already started, actually. You can kind of see here how much I've worked through it. I borrowed it yesterday and I'm doing the exercise now for chapter 2. I'm going at an okay pace, but yeah. Now this is the next book based on the same principle. This is analysis 1 plus 2, so like 1 plus 2 in German. This is a different author, Rupert Lasser and Frank Hofmeier. I'm not sure if I should pronounce the names in German or in English. Yeah, but this is way shorter than any other book in German that I've shown you, or no, any book on analysis that I've shown up to this point, except the problem book one, which doesn't count. Yeah, this was just the receipt for borrowing the books from the library. But yeah, let's quickly go look at the table of contents, since that's what's interesting. So in the beginning, like numbers. Okay, chapter 4, like metric spaces and Cauchy series. Then some more series, some differentiation, integration, Taylor series, Fourier series, compactness, normed vector spaces, total differentiation, inverse, it would say like inverse law and implicit functions. And then again, just like with the other book, like elementary differential equations, but this would be like second semester, I think. Yeah. And this book is like, I took it because it's mostly pretty short, and I wanted some other explanations, like a second opinion, if you will, from the other books. Yeah. Now the next book is pretty interesting. It's a really old book in Romanian. I come from Bucharest, which is the capital city of Romania, and we did some pretty rigorous mathematics over there. This is a book I found like at an old second-hand bookshop, and it's great. It's like a living legend from communist mathematics, which is really tough, really rigorous. It's by Walter Olariu, and it's mathematical analysis from 1981. Let's look a little bit at the table of contents. It's in Romanian, but I will try to translate it. Yeah, so here like series. This is like power series over here, chapter 1.6. Like power series and elementary functions. Then chapter 2 is metric spaces, interesting. Then continuous applications, so like continuity. This is differentiability. Interesting, has a lot of stuff, and here is like field theory and stuff. This is integrability and applications of integrability. Actually starts with the Darboux integral and then with the Riemann integral, something I've seen only in older books. Like normally newer books introduce the Riemann integral first. Let's see what next. The sixth chapter is introduction to the theory of differential equations, the Laplace transformation, and operational calculus. Chapter 7 is elements from approximation theory, and 8 is introduction to the theory of probability. So it's not really advanced. I think, like, I actually read like 2 chapters from this back in high school. I think in 11th grade when I got this book, I read a part from it and it was really tough, but now I think it shouldn't be a problem anymore. But yeah, great book, and also like a different view on things. Next is Undergraduate Analysis by Serge Lang. I actually read a little bit of Serge Lang's algebra also back in high school, and it was great. Serge Lang is a great expositor. Now I wanted to borrow this from the library just because it seemed like a great book in my journey towards like analysis. Oh, here I have like a bookmark even though I haven't started reading yet. Interesting. Now let me find the table of content. So after the foreword. Perfect. So review of calculus, then sets and mappings, real numbers, limits and continuity. This is some pretty standard order. Differentiation, elementary functions, the elementary real integral, and then part 2 is convergence, normed vector spaces, limits, compactness series. Now this part actually is pretty similar to the Romanian book, which I find pretty interesting. the integral in one variable, applications of the integral, which is part 3, approximation with convolutions, Fourier series, improper integrals, the Fourier integral, calculus in vector spaces, functions on n-space, the winding number and global potential functions, derivatives in vector spaces, inverse mapping theorem, ordinary differential equations or OEDs, multiple integration, differential forms, and that's it. This is a pretty long book as well. I've seen it's pretty rigorous. I mostly borrowed it for the amount of knowledge that it has, like like how broad it is, you know. It has like 600 pages, 700 pages. No, 600 I think. Let me see. Yeah, 600 and something. Let's say 630, around that point. And now for the last book in this video. This is the last book I would like to attempt. This is Principles of Mathematical Analysis by Walter Rudin, also known as Baby Rudin. Now this is a German edition, that's why it only says analysis, but this is basically Baby Rudin in German. I would have liked to read it in English, but I found this like German copy at the library and decided to borrow it. And it actually includes a little bit of topology in chapter 2, which is like my end goal in undergraduate mathematics, I'd like to say. It covers like metric spaces, compactness, some set theory as well. And yeah, I'm not going to talk too much on this book since it's also extremely difficult from what I've heard, from what I've seen on the internet, and by skimming through the book. I got here like a bookmark, but I don't know why. Like, I'm not gonna start this for another 2 or 3 months, I think. This is also the most popular book on the list, maybe together with the Terence Tao one on analysis. But yeah, now something that I would have liked to mention is the order that I'm going to work through. Excuse my terrible handwriting. So I'm going to start with partial, with analysis 1, 2, and 3. I'm just gonna write like here 1, 2, and 3. Why doesn't this work? Yeah, and then Lasser, which was the analysis 1 plus 2. The Forster was the problem book. Then number 6 will be the Romanian communist book. I mean, not communist, like the Romanian book written in the communist Romania. Then 7 and 8 will be analysis 1 and analysis 2 by Terence Tao. Number 9 will be Serge Lang undergraduate analysis. 10 will be Baby Rudin. But then I wrote here some extra books. Now these are books that I would like to get one day, but it's not necessary for me to get them or like work from them. The Rosenlicht Introduction to Analysis, it's a Dover publication, so it's relatively inexpensive, something like 15 euros on Amazon, like second hand, or 20 new. The Kolmogorov and Fomin one, it's great. I've seen it a lot on the internet. It's also like a Dover publication, so it's a little bit cheaper, like 15 euros, which is pretty great. I've heard only good things about it. Also, like as a bad thing, the fact that it's pretty rigorous and difficult. There is a real analysis book by J. Cummings, which would be from the series like long form textbooks. He has one on proofs, one on real analysis, one on the history of mathematics, I think, I'm not sure, or he's writing it right now. Then here is Paparudin, or like the graduate version of the other one. This is real and complex analysis. From Schaum's outlines, I would like to get vector analysis, which is important for engineering and mostly what I'm going to do later on in my graduate school and so on, if I continue on this engineering path. And also by Walter Rudin, Fourier Analysis. This is a Dover publication, so it's more inexpensive. But yeah, this has been the list. I'm hoping like I can get through most of this stuff. Now most of it is borrowed from the library, but I can extend up to 5 times, I think. So that would be like 3 or 4 months from what I remember. Yeah, like 4 months is possible. It changes all the time, like the amount of time you can extend it for, by the way. But yeah, I'm hoping I can finish Böschel 1, 2, and 3, Lasser and Forster this year. Maybe the next 3 ones, like the Romanian one and Terence Tao ones as well. But before this, I also have to finish like Schaum's Outlines of Calculus. I'm on chapter 21, and Schaum's Outlines of Linear Algebra. And also like I also want to go through some other physics books and some other math books that aren't analysis, like abstract algebra, linear algebra, and so on. Yeah, this has been the video. Hope you liked it, and please like give me some comments, like try to guide me a little bit. If you have any recommendations, leave them down below.